Okay, so this video is about applications of the law of sines and cosines. And this is our first question. A satellite dish can track the speed of a plane while recording the distance to the plane at 2 points in time and the angle through which the dish rotates. In the picture below, a satellite measured the distance to a jet at 35 miles. At 0.25 hours, or 15 minutes later, it measured the distance to the jet at 58 miles. If the satellite rotated through an angle that measured 132 degrees, determine the average speed of the plane to the nearest mile per hour. All right, so I'm going to need more space. I'm going to move this screen up a little bit. So let's try it. All right, so this is the picture we have. Assuming this is a triangle here. And what we know for certain about this triangle is that this side is 58 miles, this side is 35 miles. The angle between both of those sides is 132. So if you look at this, this has a side, an angle, and a side. So it's a side, angle, side happening. So you should think law of cosines. So that tells us which one we should be using. That side, angle, side is happening. All right, so let's go ahead and draw this again so I can write all over it without having this white background. So this is a triangle. This is 132. This is 35 miles. This is 58 miles. And this is, let's say this is side A, angle A, B, C. So this would be lowercase a. This would be lowercase b. This would be lowercase c. And I know capital A. And it asks me to figure out how fast this plane is going over this distance here. So I need to find lowercase a. So the formula says this. A squared equals a b squared plus c squared subtract 2 bc times the cosine of capital A. And I want to find lowercase a, so that's the unknown part. B is 58. C is 35. 2 times 58 times 35 times the cosine of the angle A, which is 132 degrees. And from there, I'll plug this directly into my calculator. I get a squared to be about 7305. So A is about the square root of that, which is about 85.5 miles. All right, that means the plane traveled a distance 85.5 miles, roughly, over the course of that 15 minutes. Since they wanted in miles per hour, I'm not going to think about that being 15 minutes. I'm going to think about that being 0.25 hours. All right, so I'm going to need some space, so I'll try to make it fit. All right, this is what I know for certain. I know the formula for distance is distance equals rate times time. And in this problem, I know my distance. The distance here is 85.5. So I know 85.5 equals to rate times time. Also, I know my time. Time is 0.25 hours. So I'm going to erase this and rewrite it as 0.25. So this is 0.25 hours. To solve this for R, I would divide both sides by 0.25. So R would equal to this side, 85.5, divided by 0.25. That's your rate. And if you plug it into your calculator, your rate is, and move the answer up here. Make this black. All right, so R is about 342 miles an hour. Because I took miles and I divided by hours. That's why it's miles divided by hours, miles per hour. So that's how fast the plane is going, 342 miles per hour. Had you divided by 15 minutes, you have miles per minute, which is perfectly fine, but it wouldn't be 342 because you're not going that fast per minute. And plus, they didn't ask for miles a minute. They asked for miles per hour. So we want to give it to you in the way they asked. All right, that's one example. We got one more, and that would be it. Okay, so the course of a boat race starts at a point A, and the figure 6.9 is here's figure 6.9, and this is where we start. And proceeds in the direction south, 52 degrees west. That basically means southwest, 52 degrees. So, and it means southwest from a perpendicular. So you got to think about a vertical line, and then southwest there, 52 degrees from that vertical line. So that's the reason why that's 52 degrees here. All right, so to a point B. Here's point B. Then the direction southeast, 40 degrees. So think about that vertical line again. There you go, southeast from that. That would be 40 degrees. That's why that's 40 degrees there. To a point C here. And then finally back to point A. So it didn't tell you the angle, so it went straight back to point A. Point C lies 8 kilometers directly south of point A. So this means point C is directly south of point A, 8 kilometers. Approximate the total distance of the race's course. All right, so this is what we got. This information we have. Let's think about which one we should use, law of sines and cosines. All right, but instead of waiting on me to do it, pause the video. Let's see if you can answer this video and answer this question on your own. So instead of waiting on my answer for it, actually pause the video and then see if you can actually do it by yourself. So pause it now. And then after you get done, hit play and see if you get the same thing I come up with. All right, so if you pause it, look at this triangle. You don't know this side or this side, you do know that side. This is capital A, so this is lowercase a. I'm going to redraw it so I don't have to worry about writing over that light color. So this is capital A, this is B, this is C, this is 8, 52 degrees. If this was 40 degrees here, because this is perpendicular to the ground, this is perpendicular to some line. These both are parallel lines. So by knowing these lines are parallel to each other, I know if this is 40 degrees, this is also 40 degrees. And I know the letters, the triangle is, this is C, this is lowercase c, this is A, this is lowercase a, this is B, this is lowercase b. All right, so the information we have is A, B, and C. Lowercase a is unknown, lowercase b is unknown, well, b is 8, lowercase c is unknown. Capital A is 52, capital C is 40. If you add those up, subtract from 180, leaves capital B to be 88 degrees. So I know this has to be 88 degrees. And we got enough information. We should recognize that if I have a side and an angle here matching, I can automatically use law of sines. So if I was using law of sines, I could say that 8 over sine of 88 should equal to, let's say we're going to find A. So lowercase a over sine of 52. You do the math, cross multiply. Lowercase a has equal to 8 over sine of 88 times sine 52 degrees. And that's roughly, make that look a little bit better. All right, so anyway, this is a about symbol. This is about 6.3 kilometers. So now this part is about 6.3 kilometers. And lowercase a is 6.3. So the last thing to find is lowercase c, and I'm going to use the same fraction. So I could say that b over sine of b equals a c over sine of capital C. So 8 over sine of 88 equals to c over sine of 40 degrees. And you're going to multiply by 40, sine 40 over there. So c has the equal to 8 over sine 88 times sine of 40. So C is about 5.1. So this part right here is about 5.1. This inside is 5.1. So we solved the triangle. Let's make sure we answer the question. The question actually solved the triangle. The question asks to approximate the total distance of the race, of course. So they're basically saying, what is this length plus the second leg of the race plus the third leg of the race? So what is 5.1 plus 6.3 plus 8? Well, it's about 19.4 kilometers. Is the distance of the race. And that's it. Pretty much all I have. All right, so with that being said, good luck.